Hi everyone, I'm Yasir Ali and welcome back to my channel Yastech. In our last video, we explored mesh topology where every device connects to every other device and star topology where all devices connect through a central hub. Today we are going to talk about another simple, classical and very important type bus topology. In this video, we will try to cover what is bus topology, its structure, how does it work, its advantages and disadvantages. So make sure to watch till the end to understand everything clearly. And if you enjoy learning with us, don't forget to like the video, subscribe to the channel and hit the bell icon so you don't miss any future videos. Let's get started. What is bus topology? In bus topology, all the devices in the network are connected to a single central cable known as the bus or backbone. This cable is typically a coaxial cable which allows the electrical signal to travel efficiently over moderate distances. Each device connects to the bus using a T connector. The vertical part of the T connects to the network interface card of the device, while the two horizontal parts are linked to the main coaxial cable. This lets devices tap into the bus without interrupting the continuous flow of data. At both ends of the cable, terminators are attached. These are 50 ohm resistors that absorb data signal once they reach the end of the cable, preventing them from bouncing back, which can cause interference and data collision. Now, one important feature of the bus topology is that it is passive topology. This means that the devices connected to the network do not amplify, control, or manage the data signal as they pass through the cable. They only listen to the traffic on the bus and transmit data when the line is free. There are no repeaters or switches helping the signal. The signal simply travels along the cable on its own. Because of this passive nature, the entire network depends heavily on the quality of the cable and the proper termination. If the cable is too long or has a poor connection, the signal can weaken or reflect, and since no device is boosting the signal, the network may fail. It is very imperative to understand the structure of bus. Let's have a look at it to understand the different components of bus topology in this segment of video. The data travels through the main cable known as backbone or bus, which is usually RG58 coaxial cable. There are terminators of 50 ohm resistance at both ends of the backbone. The major purpose of these terminators is to avoid the bouncing back of data signals. The devices are connected to the main cable by cable which is known as drop cable. The devices or PC are connected with the help of BNC T connectors or plugs. In this segment, we are about to discuss the working of bus topology. The working of bus topology is quite simple and easy to understand. In this setup, all the devices like computers, printers are connected to a single coaxial cable known as bus or backbone, which acts as a shared communication channel. When a device such as B wants to send data to E, it first checks whether the bus is free or not. If no other device is transmitting, it places its data onto the bus. The data then travels in both directions along the cable until it reaches all the devices on the network. However, only device that matches the destination address accepts the data, all other devices simply ignore it. At the two ends of the cable, the terminators absorb the signal once it reaches at the end of the cable. Without these terminators, the signal would bounce back and cause data collision or error. Since all the devices share the same cable, only one device can transmit data at a time. If two devices try to send data at the same time, it results in data collision. To avoid this, special rules like carrier sends multiple access with collision detection (CCMA-CD) simply are used in wide bus networking to manage access to the network bus. This section is dedicated to discuss the different advantages of bus topology. The first one is the less cost. Bus topology is extremely cost effective. It eliminates the need for expensive networking hardware, such as switches or hubs, by connecting all the devices through a single primary cable. Furthermore, fewer cables result in lower installation costs, making it ideal for individuals or business on a small budget. The second advantage is about easy configuration. The configuration of bus topology is straightforward. T connectors connect devices in a line, eliminating the need to assign roles, creating IP ranges, or managing sophisticated routing. Anyone with minimal networking understanding can put it off. The third advantage is less cabling. Unlike mesh or star topology, which required several connections for each connection, bus topology uses single backbone cable for the whole network. This implies less actual wire, which saves money, eliminates clutter, and allows for the faster and cleaner installation. The fourth advantage is its easy setup and extending. Setting up a bus topology is quick and simple. You can simply lay down the main cable, put in the T connectors, and connect your gadgets or devices in the network. Adding new devices after the network setup is equally simple. Simply put another T connector along with bus without altering the current configuration. This makes the network easily scalable. And the fifth advantage is about ideal for small network. Bus topology is ideal for small networks such as school, small businesses, or home lab, when only a few devices need to interact and network traffic is insignificant. Bus topology offers simple and cost-effective solution. And finally, we came to discuss the different disadvantages of bus topology. The first and the major disadvantage of bus topology is about dependency on backbone. One of the most significant downsides of bus topology is its full reliance on the backbone cable. This single wire transfers all the data across the network. If the backbone is damaged or breaks at any point, the entire network will stop working, or even if all of the devices are operational, the communication cannot occur without the central line. The second disadvantage is about limit on the cable length and number of nodes. There is limit on the number of nodes or devices that can be connected in the bus topology. Similarly, there is also a limit on the length or size of the backbone cable. If you connect too many devices or extend the wire too far, the signal weakens, and this phenomena is known as signal deterioration. This can result in poor performance or even failure to send data correctly. This is why bus topology is unsuitable for huge networks. The third disadvantage is about proper termination. Both ends of the bus cable must be linked to terminator, which are commonly 50 ohm resistors. These terminators are critical because they absorb signal at the end of the wire and prevent signal reflection. If even one terminator is absent or loose, the network might become unstable with the data collision and signal loss. The fourth disadvantage of bus topology is it is difficult to troubleshoot. Finding and fixing faults in bus topology can be quite difficult. If the network goes down, it is difficult to determine whether the problem is with the connector, the cable, a terminator, or one of the devices connected to the network. Because all the devices share the same line, a single defect can damage the entire network, and you may need to individually test each segment. And finally, the last disadvantage of bus topology that it is not ideal for heavy traffic. A bus network allows just one device to communicate data at a time. Collisions occur when numerous devices attempt to deliver data at the same time. This makes the bus topology an unsuitable choice for the network with high or steady traffic. As more users are added, the performance rapidly diminishes, resulting in delays and poor speeds. Thanks for watching this video. If you people are having any question, then you can drop in the comment section. I will try my level best to respond to your queries.